students, myself Dr. Divya, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will discuss the numerical problems on temporary and permanent hardness that to be calculated in the degree clerk units. So let us have a glance on what are the units that are used and what are the formulae that is used for calculating the hardness. So degree of hardness is calculated by the weight of hardness causing salts like sulfates, bicarbonates and chlorides that are responsible for the hardness that is causing in the salt. So they will be restricting the formation of lather that is causing problems in the industrial usage. So these hardness causing salts is divided with the molecular weight of that particular hardness causing salts. For example, sulfates, bicarbonates and chlorides in the compound formulae like calcium chloride or calcium bicarbonate or magnesium bicarbonate. Like this. So we take the molecular weights of these compounds and multiplied with the 100, that is the molecular weight of calcium carbonate, because the most present hardness causing compound is calcium carbonate. So we take and represent in the form of equivalence of calcium carbonate. Therefore, we multiply with 100. So there are several types of salts that are present causing the hardness to that particular water. So this is the molecular mass. These are the molecular masses we will be using in the further calculations, and this is the equivalent weight, and this is the multiplication factor that is done using the 100 molecular weight of calcium carbonate. So we also have the units. What are the units that are present for representing the hardness of water? Like we have in the ppm. ppm is the parts per million, ppm. It is also known as mg per liter, which is milligrams per liter. So these are the units that are widely used for representing the hardness of water. In some countries, we also show it in the form of degree clerk and degree French. So these are other units that are used in the representation. So there is a very good conversion units that are used to convert from ppm to mg, that is equal, but however we have 0.1 degree French that is to be used for converting the ppm to degree French, and also we have 0.07 degree clerk. So 1 ppm is equal to 0.07 degree clerk. So in this session we will be using we will be converting degree, ppm or mg per liter to degree clerk. So for that, the whatever we get, the concentration in or the hardness of water in ppm or mg per liter will be multiplied with 0.07 degree clerk to attain X amount of degree clerk. So this is the final answer we will be obtaining. So and similarly we have like 1 degree clerk is equal to 1.433 degree French. So whenever they are giving question containing degree clerk units, we have to convert accordingly so that we get appropriate forms units that to be used for the expression. And 1 degree French is equal to 10 ppm is equal to 10 mg per liter or 0.7 degree clerk. So whenever there is any problem containing 1 degree French, it is equal to 0.7 degree clerk. Now let us see the examples like numerical problems on the temporary and permanent hardnesses. So a sample of water contains 50 mg of calcium 2+ ions per milliliter. Calculate its hardness in terms of calcium carbonate equivalent. So we will be using this formula: degrees of hardness is equal to weight of hardness causing salts by molecular weight of hardness causing salts into 100, that is the molecular weight of calcium carbonate. So this is the formula we will be using. And now if we come back to the contents that are present in the question, the amount of calcium plus 2 ions is 50 mg per liter. So this is like they have given mg per liter of water sample. So mg per liter, so or ppm. This is the concentration of calcium ions that are present. And we know that the molecular weight of calcium is 40, and the equivalent weight of the calcium carbonate will be like, we will be converting into calcium carbonate. So 100 divided by 40, that is the molecular weight of the calcium, into 50, that is the concentration given in the question. Like the sample is containing, water sample is containing 50 ppm of calcium 2+ ions. So that is giving to a value of 125 mg per liter or ppm. So this is given in the ppm. So now we will convert into degree Clerk units. So 125 mg per liter into 0.07, we get 8.75 degree Clerk. So this is the amount of hardness that is present in the particular sample in the equivalence of, expressed in the equivalence of calcium carbonate. So if you see here, they have given the calcium ion. They just mentioned the calcium ion. So we cannot specify it is as a temporary or permanent hardness. So we have to just give it as like hardness of that particular water is 8.75 degree Clerk. Next, calculate the carbonate and non-carbonate hardness of water sample whose analysis is as follows. Calcium bicarbonate is having 40 ppm, 40.5 ppm. Magnesium bicarbonate is 36.5 ppm. Magnesium sulfate is 30 ppm and calcium sulfate is 34 ppm. It also has calcium chloride, which is 27.75 ppm, and sodium chloride 10 ppm. So we know that water carbonate and bicarbonate hardness, it is nothing but carbonate is a temporary hardness. Non-carbonate are nothing but other than carbonate species that are present in particular water sample. So that is permanent hardness causing salts. So to be very clarity, like it is nothing but the temporary and permanent hardnesses they are asking for, and sodium chloride doesn't contribute to any hardness. So now we will be using this formula. Degree of hardness is equal to weight of hardness causing salt by molecular weight of that particular corresponding salt into 100. That is the molecular weight of calcium carbonate. So temporary hardness is equal to, like if we see, this is the calcium bicarbonate concentration that is present. This is the magnesium bicarbonate that is present. So carbonates or bicarbonates of salts are responsible for the temporary hardness. So we are taking this into consideration. 40.5 into 100 by 162 is the molecular weight for the calcium bicarbonate, and 36.5 into 100 by 146 is the molecular weight for the magnesium bicarbonate. And we get 25 plus for this. We get 25, and for this also we get 25. 25 plus 25 is equal to 50 ppm. 50 ppm that we have to convert into degree Clerk. Now the question is like, we are converting the units into degree Clerk. Whatever the question is, we get the hardness in the form of ppm or mg per liter, because the molecular weight is in the form of gram per liter, and this will be mg per liter. So therefore we get in mg per liter only. Therefore, we have to ultimately convert into degree Clerk or degree French depending on our feasibility. So we have to multiply with 0.07 degree Clerk, and we get 3.5 degree Clerk. And permanent hardness is due to chlorides and sulfates that are present in any water sample. So if you see, this is like magnesium sulfate that is present, and calcium sulfate and calcium chloride. So these three are responsible for the permanent hardness of that particular water sample. So we are taking 30 into 100 by 120 molecular weight of magnesium sulfate, 34 into 100 by 136 molecular weight of calcium sulfate, and 27.75 into 100 by 111. So this is the molecular weight for the calcium chloride. And we get again 25 plus 25 plus 25, and we get an answer in the form of ppm 75, and for conversion multiply with 0.07, and it is 5.25 degree Clerk. If you see this sample, it has a high permanent hardness when compared to temporary hardness. Next, calculate the temporary and permanent hardness in degree clerk of a water sample containing carbon dioxide 20 mg per liter, calcium bicarbonate 20 mg per liter, magnesium bicarbonate is 25 mg per liter, and HCl is 8.4 mg per liter, aluminium sulfate is 40 mg per liter, and magnesium chloride is 12 mg per liter. All the sulfides and chlorides are responsible for permanent hardnesses, and bicarbonates and carbonates are responsible for the temporary hardness. So now we will be using this formula. Degree of hardness is equal to weight of the hardness causing salt by molecular weight of hardness causing salt into 100 is the molecular weight of calcium carbonate to express it in equivalence of calcium carbonate. So temporary hardness due to the bicarbonates of calcium and magnesium. So we will be substituting the values here. This is the calcium for calcium. This is the magnesium ions that is present, and the aluminium ions that is also present here. So we will be using the 100 as a molecular weight of calcium carbonate by 44 is the molecular weight for that particular salt, and we get the value of 44.45 plus 12.35 plus 17.12, and we get an answer of 74.92 ppm. And for conversion, we have to multiply with 0.07 and we get 5.24 degree clerk. So this is the temporary hardness that is present in that particular water sample. Now permanent hardness is due to chlorides and sulfates ions that are present. So 8.4 is the HCl that is present, then 100 by molecular weight of that particular species plus 40 into 100 by, this is the sulfate ions that are present. 100 by 114 is the molecular weight for aluminium sulfate. Then is the magnesium chloride is present in the sample. So 12 into 100 by 95, we get 11.83 plus 35.09 and 12.63. So we get an after addition we get 59.55 ppm. So for conversion, we have to multiply with degree clerk. 1 ppm is equal to 0.07 degree clerks. Therefore, this many ppms is nothing but into the 0.07 will give 4.16 degree clerk. So this is how we have to convert from ppm or mg per liter into degree clerk. Next, a sample water sample has the following analytical report. So they have given carbonate form. So magnesium carbonate is 84 ppm. Then calcium carbonate is 80 ppm. Magnesium sulfate is 30 ppm. And calcium sulfate is 34 ppm. NaCl or sodium chloride is 10 ppm. Ferrous oxide is 56 ppm. So we know that ferrous oxide doesn't contribute to no role in the hardness, and also the NaCl has no role in the hardness. Now calculate the temporary and permanent hardness that is present for that particular water sample. We use the same formula, weight of the hardness causing salt by molecular weight of the hardness causing salts into 100 is a molecular weight of calcium carbonate, and we substitute in this like magnesium carbonate, magnesium carbonate, this is the magnesium carbonate, calcium carbonate that is present in the particular water. So 84 into 100 by 84 is molecular weight for the magnesium carbonate. 80 into 100 by 84 is a calcium carbonate. So we get 100, this is 80. So we get 100 plus 80 is equal to 180. So 180, we get 180. After calculation, like we will be converting into degree clerk. Multiply with 0.07 and we get 12.6 degree clerk. Permanent hardness is like due to sulfates and chloride ions that are present in particular water sample. So in this question, we have only sulfate ions that are responsible. So 30 is from magnesium sulfate and calcium sulfate is responsible for the permanent hardness. So 30 into 100 by 120, 34 into 100 by 136 is the molecular weight is equal to 25 plus 25, that is 50 ppm, and we convert into degree clerk by multiplying with 0.07 and it is 3.5 degree clerk. If we see this high temporary hardness, low permanent hardness. So that can be removed. Temporary hardness can be removed. Most of the temporary hardness can be removed by boiling. So in this particular sample, the temporary permanent hardness is low, so therefore boiling is sufficient for that particular water sample prior to its usage in any of the appliances or equipment. Next, calculate the temporary and permanent hardness of a water sample with the following data. Calcium bicarbonate is 4 ppm, magnesium bicarbonate is 3 ppm, magnesium sulfate is 3 ppm, calcium sulfate is 5 ppm, and calcium chloride is 7 ppm. We have lot of calcium salts here in this sample. So we will be calculating the degree of hardness. Weight of hardness causing salt by molecular weight into 100 is the molecular weight of calcium carbonate. So temporary hardness is due to bicarbonates or carbonates that are present. So 4 into 100 by 162, and this is the calcium bicarbonate and this is the magnesium bicarbonate. So 100 by 3 into 100 by 146, and after addition we get 4.51 ppm. So this we have to convert into degree clerk. For that, multiply with 0.07 degree clerk and we get 0.315 degree clerk of temporary hardness. So this is the temporary hardness of particular water sample. Next is the permanent hardness. So 3 into 100. How this is because of magnesium sulfates. Magnesium sulfates that are present, sulfides or chlorides that are present in that particular sample. So magnesium sulfate is 3 into 100 by 120. 5 into 100 by 136 is for the calcium sulfate, and 7 into 100 by 111 for the calcium chlorides. So the chlorides and sulfates are considered for the permanent hardness, and upon addition we get the value of 12.47 ppm or mg per liter. 12.47 mg per liter or ppm. Parts per million. So after that we have to convert into degree clerk. So that is multiplied with 0.07 and we get 0.87 degree clerk. So this sample has very low hardness, of course, but still we require treatment and also boiling before its usage in any of the industries. Next, a sample of water is found that contains following analytical data in milligrams per liter. Milligram per liter is nothing but ppm again. ppm having magnesium bicarbonate is 14.6, magnesium sulfate is 6, calcium bicarbonate is 16.2. So calculate the temporary and permanent hardness in parts per million and degree clerk. So first anyway we get the values in ppm and then we convert into degree clerk by multiplying with 0.07. Now we will be using this formula. Degree of hardness is equal to the weight of the hardness causing salt by molecular weight of the hardness causing salt into 100, and put it in a table like magnesium bicarbonate is 14.6 and its molecular weight is 146. So 14.6 into 100 by 146 we get 10. In similar way for the magnesium chloride, it is 9.5. 95 is the molecular weight, and 9.5 into 100 by 95 we get 10. And for magnesium sulfate, it is 6. Molecular weight for the magnesium sulfate is 120, and 6 into 100 by 120 we get 5 ppm or mg per liter of hardness. Then calcium carbonate is 16.2 and its molecular weight is 162, and after calculations we get 10. So this is how we have to calculate and then apply for the temporary hardness and permanent hardness. So what are the salts that are causing temporary hardness here? This is temporary hardness, bicarbonate. This is temporary hardness. So these two are permanent hardness causing salts. So temporary hardness is due to bicarbonates of calcium and bicarbonates of magnesium. So 10 plus 10 we get 20 mg per liter, that is causing hardness temporary. Next, converting into degree clerk, multiply with 0.07 and we get 1.4 degree clerk. For permanent hardness, chlorides and sulfates are responsible. So 10 plus 5 is 50 and multiply with 0.07 and we get a value of 1.05 degree clerk. So temporary hardness 1.4 degree clerk. This is temporary hardness, this is permanent hardness. Temporary hardness is high compared to permanent hardness. So this sample also requires vigorous boiling before its application. Then a sample of water gives an analysis of 13.6 mg per liter of calcium sulfate, 7.3 mg per liter of calcium magnesium bicarbonate. So we have one bicarbonate salt and a sulfate salt. So now calculate the temporary and permanent hardness in degree Clark. So only one salt is responsible. This is temporary hardness, and this salt is responsible for the permanent hardness. So we use the formula again: degree of hardness is equal to weight of hardness causing salt by molecular weight of hardness causing salt into 100, and calcium sulfate is 13.6 here, and the molecular weight is 136. So 13.6 into 100 by 136, we get 10. And for the bicarbonate, this is capital. So for the bicarbonate, it's 7.3 mg per liter. So 146 is the molecular weight. 7.3 into 100 by 146 is 5 mg per liter. Now we will be calculating the temporary hardness. It is nothing but the 5, that is only one salt is responsible. So multiply with 0.07 to get in degree Clark, and we get 0.35 degree Clark. Now permanent hardness is due to calcium sulfate, that is 10 mg per liter, and multiply with 0.07, we get 0.7 degree Clark. So these are the values we get for this sample, particular sample, wherein only one salt is responsible for the hardness causing salts. So temporary hardness is equal to 0.35 degree Clark, and permanent hardness is equal to 0.7 degree Clark. So whenever we are giving any values, if it is 2 digits, we have to give this also in 2 digits. So 0.70 degree Clark. So this is high. Permanent hardness is high compared to temporary hardness. So it definitely requires a chemical treatment with the chemical agents or reverse osmosis or ion exchange method before it is used for any applications. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.